Okay, for this problem 9.45, we have to find the mass of the disk. So first I wrote down the information we got right here. So we got that the radius is 0.30 meters, mass 4.35 kilograms, the distance is 3.10 meters in 2.03 seconds, and the initial angular velocity is 0 since it started at rest, and we're looking for the mass. So first of all, we gotta start using this motion formula to find the final velocity. So we have to plug all the information we got in the formula. So we got that 3.10 equals 1/2. So we're looking for this plus the initial, which is 0, times 2.03. So that's going to give us the final velocity, which is 3.05 meters per second. So now we're going to use our rational motion formula, which is velocity equals r times w, which is the angular velocity. So it's 3.05 equals 0.3 angular velocity. So that's gonna give us 10.17 per second. So that's the first. Okay, now for the second part. Now that we have the angular velocity, we're gonna use the k initial plus u initial equals k final plus u final. So since k is a rest at the beginning, is 0 plus m times g times y equals 1/2 times I plus 1/2 mb squared. So now I'm gonna plug all the numbers we got. So it should look like this: 4.35 times 9.8 times 3.10 minus 1/2 times 4.35 times 3.05 squared, and that's equals to 1/2 IW squared. So if you solve in this, I equals 2W squared 1.9, and now we're gonna plug this number in here. 2 times 2 over 10.17 squared times 111.9, and solving that, it gives you the inertia. It gives 2.16 kilograms times m squared. Okay, and for the last part, we're gonna use a rotational dynamics formula, which is the inertia equals 1/2 mr squared. And now we're gonna solve for the mass, which it was what we were looking for this whole time. And we plug the numbers that we got in the formula. So we got 2.16, 1/2 m 0.300 for the radius squared. And solving that, you finally get 48 kilograms. And that's the final answer.